I'm about to tell you something that's probably going to sound completely insane. It's something that goes against every single experience you've ever had. I'm talking about the feeling of touch. Because, and I'm not kidding here, it's all an incredibly convincing illusion. You've never actually sat in that chair you're in. And right now, there's an invisible force field between your fingers and the device you're holding. Let's break down how this is even possible.
Yep, you heard me. Let me say it again, just so it sinks in. You have never, not once in your entire life, physically made contact with another object. That sounds crazy, right? It feels wrong. I mean, if you're not really touching the chair you're sitting on, or feeling the floor under your feet, then what is that sensation? What's that feeling of solidness, of pressure? Well, to figure this out, we need to zoom in. And I mean way, way in. The whole secret starts with the tiny little things that make up you, me, and literally everything in the universe, atoms. And the truth about what an atom actually looks like, well, it's one of the most mind-bending ideas in all of science. Okay, to really get a handle on this, let's do a little thought experiment. Picture a massive football stadium. You know, one of those giant ones that holds like 80,000 people. Now imagine we could blow up a single atom to be that big.
So where's the stuff of the atom? The nucleus? It's sitting right there in the middle of the field on the 50-yard line. But here's the kicker. At this scale, it's no bigger than a single tiny pea. And almost all the mass of that entire stadium-sized atom is packed into that one little pea. So what about the electrons? Where are they? Well, they're like impossibly small specks of dust, just zipping around way up in the nosebleed seats, the absolute highest, farthest points of the stadium. And all that space between the pea on the field and the dust in the stands, it's just empty.
And that's the big takeaway here. Every single atom that makes up your body, the desk in front of you, the air you're breathing, it's 99.99% empty space. Which leads to a pretty wild conclusion. You, me, all of us, we're mostly nothing.
And if that number doesn't blow your mind, get this. If you could somehow just squish all that empty space out of every atom of every human being on the planet, you could fit the entire human race, all 8 billion of us, into a space the size of a sugar cube. So that brings up a pretty big question, right? If we're all just walking clouds of empty space, why don't we just fall right through the floor? The reason we don't just ghost through walls isn't because we're solid. It's because there's an invisible war happening on a scale you can't even imagine. And the reason you feel solid is all thanks to one of the most basic forces in the universe. See, every atom has that cloud of negatively charged electrons whizzing around it. And what did we all learn in science class about charges that are the same? They push each other away. So when the electron clouds from the atoms in your hand get super close to the electron clouds of, say, a table, they start pushing back against each other, hard. So that feeling of solid you're getting, it's not contact, not even close. It's that electromagnetic repulsion force. In reality, you are hovering, literally levitating, just a few nanometers above the surface of your chair, floating on an invisible cushion of pure force.
Now, you might be thinking, okay, fine. But what if I just push really, really hard? Surely I can get past that little force field? Nope. Because even if you could, the universe has another even weirder rule that's going to stop you dead in your tracks. This one's called the Pauli Exclusion Principle, and it is one of the most unbreakable laws in all of physics. Think of it like a cosmic no trespassing sign. Every electron has its own unique spot, its own little address in the universe, and it will absolutely not let another identical electron move into its space. The best way to picture this is with a simple ceiling fan. When the fan's off, you can easily stick your hand between the blades, right? There's plenty of empty space. But turn it on, and those blades start spinning so fast that they create what feels like a solid, impenetrable disk. The electrons in an atom move so insanely fast that they do the same thing, creating a kind of energy shield that nothing can get through. All right, so if our atoms never touch, what is the sensation of touch? What are we actually feeling when we sense pressure or texture or heat? It turns out it's all just a brilliant trick played on us by our own brains. Our intuition, what we think is happening, is that the atoms of our skin are bumping up against the atoms of an object. But what's actually happening is that our nerve endings are like super sensitive detectors. They just sense how strong that electromagnetic repulsion force is, send a message up to the brain, and our brain creates the sensation that we call touch. So let's break that down. When you feel pressure, that's just your nerves measuring how strong the pushback is. When you feel the warmth from a cup of coffee, your atoms aren't touching it. They're just getting jostled by the energy from the faster vibrating atoms in the mug. And pain? That's just your brain's alarm system screaming that the repulsive force is getting way too intense.
And now for the big finale. We've seen that the universe has layers of rules, all designed to keep atoms from ever actually touching. But what if they did? What if, just for a split second, all those laws just failed? Just imagine it. You push your hand through that electron force field, you somehow ignore the Pauli Exclusion Principle, and you manage to force the nucleus of an atom in your finger to make direct contact with a nucleus in the table. What happens in that one tiny moment of true, actual contact? The result would be nuclear fusion, the same process that powers the sun and every star in the sky.
Yeah. Merging those two nuclei together would unleash a catastrophic amount of energy. To put it simply, you and the thing you touched would basically explode with the force of a nuclear bomb. So our inability to touch anything isn't a weird bug in the system. It's the universe's most important safety feature. It's what keeps everything stable.
So does knowing this make the world feel less real? I actually think it does the opposite. I think it makes it more magical. The next time you hold someone's hand, remember you aren't just feeling skin on skin. You are feeling the fundamental forces of the cosmos at play. A beautiful, invisible dance of energy connecting you to that. And it really makes you wonder, doesn't it, if our most basic, fundamental sense of touch is really just an illusion, an interpretation of forces and empty space. What other truths about our reality are just our brain's best guess at what's really going on in this strange and beautiful universe? Something to think about.